Our electricity unit starts with nothing that looks very electrical. I've got a piece of bubble wrap, a glass rod, and these two funny jars in front of me. They're just empty jars that I've punched a hole in, hung a wire through them, and there's two pieces of aluminum foil dangling off that wire. And at first, it doesn't really look like much happens with this connector looking device when I touch it with a rod. But our understanding of electricity actually started in a painful way. When people scuffed their feet on carpet and touched metal objects and got zapped. I'm sure that's happened to you a lot. So rubbing, friction, seems to have something to do with electricity. And these jars will actually show us a lot about electricity if I rub this rod and this plastic together. So I think you know that the plastic and rod are both made up of different molecules, which are made up of atoms. And each of these materials has electrons flying around the outside of its atoms. Because they're different, those atoms want electricity differently. And when you rub things together, something amazing happens. Do you see those foil leaves? The more I touch this glass rod now to them, they push each other apart. That's because this glass rod is now electrically charged. Actually, this piece of plastic is too. One of these materials wanted electrons more than the other, so it took them as I was rubbing them together. Because there's two materials, and because somebody's taking electrons and somebody's losing them, that means there has to be two types of electricity. And they're the things that you've learned by now are called positive and negative. One of these, which is negative, got the extra electrons. One of them, which is positive, lost them. So, long before anyone knew what an atom or an electron was, people were studying this and had figured out that there were two types of electricity. Ben Franklin actually was the one who gave the names to the two types. And he said the type that this rod got was positive. That's why positive things have lost electrons, because Ben Franklin said so. But a lot can happen with electricity. And the fact that there are two types and that various materials have these two types means some really interesting stuff happens. Check out my jar. You can see that their two pieces of metal are repelling each other. And the reason is they all got the type of electricity from this glass rod. The wire, the foil, they have that positive electricity. And positives, a lack of electrons, repel each other. So that's why they're pushing apart. But check this out. I'm just going to touch this. And it's like all the positive electricity was lost. Well, what happened? I have both kinds of electricity in me because I have lots of electrons and protons. So when I touch that collector here, some of the electrons in me jumped in there and canceled out some of that positive charge, so they stopped pushing each other off. So these devices actually can be used to check what kind of charge something has, whether it has positive or negative. And even things like me that are neutral can sometimes cancel out excess charge. I'm starting this video with two positively charged electroscopes. I charge them both by rubbing this glass rod on this plastic bubble wrap. And as you can see, when I bring it near one of them, it separates the leaves even farther. Why? Well, we have a positive charge on the rod, and that draws negative charge out of the electroscope, giving it a positive charge, and then the two arms repel each other because they're both positive. So bringing another positive charge in makes them go even farther. You can actually use this as a test, though, to see if maybe we had a different charge that we were putting on the electroscope. So in this case, I've got a rubber rod and a piece of fur. I'm going to do exactly the same thing. But watch what happens when I bring this near the other electroscope. They decrease, and then when I touch it, it goes back out. What's happening there? Well, this rod actually acquired a negative charge. And as I brought the negative charge close, the positive charges actually moved out of the foil leaves and up to this knob because they were so attracted to this negative charge. And that made the arms drop. They started to go back out a little bit once I touched it, because then this electroscope actually got a negative charge. And that's why you saw it behave the way it did. So you can use the different electroscopes to tell whether a charge is positive or negative. For example, I have this stuffed animal here. I'm going to rub it on my shirt. I'm going to bring it near the positive electroscope. As you can see, the leaves start to go back together as it gets close. So that implied that the bird acquired a negative charge.